Right. Up to now, we have discussed about our lesson, microcontrollers lesson, and we already learned about three different microcontrollers, Raspberry and Raspberry we just introduced, and Arduino we have introduced, and next one is microbit. Actually, here in this lesson, we were discussing about sensors, and today also we will be continuing to learn about the sensors. Last day, what we have discussed, we have discussed about breadboard connection, right? I just gave you the technical idea about how to connect to the breadboard and how can we operate with a breadboard. And today's lesson, so let's learn about the sensor implementation of it. And you can see in the page number 58, there are some sensor related codes in microbit. So this you can use. The microbit related or this sensor related code or microbit, we can use to code. And this is really, really easy. But so in this Arduino based thing, implementing sensors is not difficult, but it has some fundamentals. You have to learn something before implementing. Here you can drag and drop the code, and anyway acceleration can be taken by dragging this part. Light level can be taken by dragging this component. Just dragging and dropping. The circuit is already created for you. Therefore, dragging and dropping the code will solve the problem, and it will it will automatically get the input from the sensor. Right. Let's see how can we implement that using Arduino today. So please log into Tinkercad. First of all, please log into the Tinkercad. And the sensor that we are going to learn today is, today we are going to discuss about PIR sensor, passive infrared sensor. So please write down the heading. Please write down the heading PIR sensor. PIR sensor, passive infrared sensor. Please write down in your new note. This sensor is sensing the change of infrared This sensor is sensing the change of infrared field, infrared signal fields. By using this, we can identify a moving person or moving part of a person. Moving person or moving part of a person as people emits an infrared signal. No, actually, I didn't release the note. So that is the reason why you are not getting note. I didn't release it yet. So please write down this. Here we use PIR sensor as input and LED bulb as an output as the output. Here we use PIR sensor as an input, and LED bulb as the output. Create the following circuit. Create the following circuit. Right, let's see. So in this circuit, what you need to do, so you can take a screenshot of this and add it to the node, or you can draw it quickly. So please see the pin diagram. This is very important. So PIR, this is the PIR sensor. It has 3 nodes. So one node is like that is a ground node. So you can see this is connected to GND. That is the ground node. Let me zoom. Right, this is connected to GND node, which is ground, and the middle pin is basically connecting to the 5 volt for power. And this is the signal node, and I have connected that to the pin number 8. You can connect to any pin number. I have connected it to pin number 8. You can do this using Tinkercad, right? Tinkercad the link කරන්න පුළුවන්. එහෙම නැත්නම් යන්දලා පස්සේ කරන්න පුළුවන්. Tinkercad the link කරනවා නම් හොඳයි. If you can do this using Tinkercad. Then LED, anode of the LED I have connected to the 7, and the cathode I have grounded, right? Cathode එක ground කරා. Anode එක 7ට connect කරා. මෙතනත් signal එක 8ට connect කරා. Then these two I have grounded. 5 volt is given to this. This I have grounded, and this the cathode I have grounded in the LED. So please create this circuit using Tinkercad quickly. If you have any question, you can ask. I'll help, right? So today it's very difficult to me to talk, but just trying to do the lesson. So it's very tired. This is the 4th lesson that I'm doing today. So please do it quickly and let me know once you're done. For those who have not created, let me show the steps. Move into the Tinkercad and the circuit creation interface. After that, I'm getting Arduino. Here's my Arduino board. Then I'm getting an LED. Connecting the anode to number 7. And let me ground the cathode. Then so I need PIR sensor, passive infrared sensor, because this sensor is capturing infrared signal. So when I get that, you can see there are 3 nodes. The first one is G brown. When you go there, you can see it is brown. So you have to ground that. Okay. Then the second one, it is power. Power means you have to give 5 voltage. I can give that using 5 volt pin here, this one. So then the next pin is signal. Signal pin, I can connect that to the pin number 8 or any preferred pin that you like. So here, this is my circuit. Okay, please do that. And the next thing is, actually you can do the same using this is a microbit. I'll show the same. So this one is sorry, Still same thing you can see. So microbeat they have connected these 3 pins, GND pin to the ground. Here the black one is not GND pin to the ground. Then this is red color pin, that is 3 volt. So since 5 volt is not available, 3 volt is given. Then this other signal pin to the 0, connected to the 0. Then there's a speaker. Speaker has 2 things, that is GND pin as well as the 5 volt pin. Here it's connected to GND, GND, and signal is given through the pin number 2. So that is the pin diagram if you are connecting micro:bit, but don't do that now. Later, let's see the micro:bit version of this, right? For the moment, I'll erase it because I don't need that. For the moment, I'll erase this, but later I'll show you that micro:bit version also. So please create this one. This is Arduino version. Okay, this is the zoomed version. You can see it very well. The code, that is very important. I'll explain the code and I'll give you the note on code, right? So let me select, when I click the code, I will get the block code version. I'm going to select text code and remove the block codes. That's the text code. Just continue. You will get this. And then please introduce your pins. So you need pin number 8 to be connected to the PIR. I'm filling INT PIR equal to 8. That is pin number 8. Then INT LED. That is pin number 7. I'm filling it's 7. So these are actually assigning values to these 2 pins. And these names, hereafter we are going to use these names, right? PIR and LED. I have already given them values. The values are actually these pin numbers. Then pin mode, I have to set the LED pin to output. And also pin mode, I have to set the PIR pin to input. The loop is the place where the things get repeated. First of all, I have to read INT result. I'm getting another variable called result, and I'm assigning the digital read or digital read PIR. If I detect any motion, if result equal to high, if I detect any motion, what should I do? So I need to turn on the LED. I can say LED pin, actually digital write the LED pin. I'm going to write high voltage to that and keep it delay for 1000 millisecond, which means 1 second at least. Or you can keep it for few seconds, 2 seconds. That is even okay. As the second part, else means if no motion detected, I'm going to copy and paste the same code again, digital write LED, but this time I'm going to lower the LED. Sorry, LED to low, lower the LED and keep 2000 milliseconds. If everything works, so see, it's very small code. If everything works fine, when I play this or when I start the simulation, oh, I got an error.
So input can go all capital and non.
Yes, that is the problem. Pin mode LED output and LED PIR input. Let me start the simulation. The capital simple matters. Yes, now no errors. So let's remove the code in. and click on this PIR sensor, you can see the simulation gives us the thing to move. This, you can assume this as the person. You can move it. Okay, when you're moving, you can see the LED is turned on and it will be turned off after stopping the motion. When there is a motion, when motion is detected, you can see the LED turns on. Actually, I need to reduce the delay, otherwise like it's problems. Let's reduce the delay to 1000, right? Otherwise the feedback will be delayed. So let's simulate. Now you can see when I start the moving, you can see lighten up LED, and then when I stop the motion, it will turn off. Start the motion, you can see it's lighting up. When I stop the motion, start the motion, you can see it's keep lighting up when I start moving. But when I stop moving, you can see it will turn off. Okay, good. So please write down the code after creating the circuit. Now you can see circuit and code both. Please do it quickly. So the next thing is like we need to explain the code. So what has happened in each line of the code, you need to explain. So let's do that now. Please write down with me. So this is the code and I need to explain each line. And I'm going to write it in front of the code using a comment, right? These comments will be ignored by, the comments will be ignored by the comments will be ignored by the IDE or whatever the place that is executed. So here comments means you have to put slashes and then a forward slashes and then write. So for an example, PIR, this says you can say declares a variable called PIR and assigns value 8 representing pin number 8. So likewise, I can write that. So even after that, I can execute, and that doesn't affect the code, right? So that is why these forward slashes are used for comments. Comments are explaining the code segments. So please add that to the note. I'll write it in Word, so it's easy to understand, right? The first line, int 8, and that declares a variable called PIR and assigns the value 8 representing pin number 8. So similarly, sorry, here LED, right? Sorry, my mistake. This is LED and value 7 representing pin number 7, and this is the second one. Declares a variable called PIR and assigns the value 8 representing pin number 8. Void setup. One-time function to prepare the environment. This is that setup function is one-time function. It will execute only one time, and that prepares the environment. Then pin mode LED is output. Prepare LED pin or pin 7 for accepting an output. Next one is actually prepare PIR pin that is pin number 8, for accepting an input. Loop function, so the next one, loop function is a continuous function which will continue to repeat, Then int results is declaring variable named result and assign PIR pin value, which is red. If result is equal to high, there is moving person. So that is the detection. Actually, I'm running a loop here. I didn't give that in the code, but here I'm running a loop. I'll explain that again. Repeating from k equal 1 to k equal 5, actually 5 times. 5 times repeating is done. High voltage is sent. High voltage means basically 5, right? Is sent to LED pin or pin 7. LED will turn off because you are sending as it gets required voltage. Keep that LED delay 100. Keep that LED status for 100 milliseconds, which is equal to 0.1 seconds. Low voltage or 0 volt is sent to the LED pin. For pin 7, an LED will turn off. Then keep that status, keep that LED status for 0.1 seconds. Actually, this part will blink LED for 5 times. This part will blink LED because it's happening from K1 to K5 5 times. LED on 100 millisecond, off 100 millisecond, on 100 millisecond, off 100 millisecond. This will happen for 5 times. Please write down. Just still writing. So this is what we are writing. Okay, else. If result variable get low voltage status, then low voltage is sent to the LED, and LED will turn off as no voltage is there, and it keeps the status for 1000 milliseconds. 1000 milliseconds, which means 1 second. So please write the code quickly with the explanation. Right. So let's add this part also to the code where we didn't add this repeating code. And yeah, this way you can edit this by adding the code in second. Let's stop the simulation. And you can say for int k equal 1 and k less than or equal to 5, k plus plus. So repeat 5 times. Then the curly brackets. Curly brackets here. Let's copy and paste this one more time, sorry. So let's add the code segment now, and I'm going to turn on 100, turn off 100. So this is low. And so let's see what will happen now. Let me run. When you move this, you can see it will blink 5 times, right here. Click and move this. It's blink 5 times. It's blinking 5 times, right? Okay. So that is what happened when I had this blinking code. Right. As I said, the PIR can be added the other one also, into the other one also. So let me take a new file. So I hope you have finished this. So the same thing can be done with the other sensor. So let's take a new file, a new project. Go back. I said that using this microbit, it is very, very easy. Right? In microbit, it's very easy to implement this. Okay. So let's search for PIR. And this is the microbit version of PIR implementation. Actually, it uses not just the microbit circuit, it is using PIR sensor, which is connected to. So you can see the here, this is the ground, and this is the 5 volt or 3 volt is given, and signal is connected to the 0. And here minus is connected to ground and plus is connected to 2. Okay, so what is the code? So see the code here. So this is the microbit version. On start, analog set pitch pin is P2. That is like this one. So there is an analog pitch. So this analog pitch is set to P2. So this can be set to P1 as well. This is where the speaker, piezo speaker is connected, that is giving small sound. And then forever, if digital pin P0, you are reading the P0 pin, and if it is equal to 0, so show LEDs, you are showing LEDs this pattern, and if not, you are showing LEDs this pattern, right? So basically, here this is the analog pitch. You are changing the analog pitch 3 times. Analog pitch. So else means then when there's a motion detected. 0 means no motion. 0 means nothing is there. So here it will be displayed like this. But when there's a motion, the analog pitch will be changing for 440 and for 200 milliseconds. You are playing this sound and keep that status for 100 milliseconds too. So there is a delay. The delay part is, so it's very, very easy. Right, let's play this and see. Okay, initially you can see this right sign, that means no motion is detected, right? But when I click this and let's move, can you see? It emits a sound, right? Here it emits a sound. Actually, you can change the hertz levels. You can change it to 128, 512. So likewise, you can change it. So if you know the hertz level, you can change it to, even you can generate music, right? And like high frequency, you can change it to like 512 or 1024. That is very high frequency. So it indicates the motion is detected. Right? This is the same sensor, same PIR sensor, how we can connect that to microbit board and programming. In programming. Okay. Right. This is easy because the wiring diagram is already there. So you can just import and test that. So the next day, my plan is discuss about, so now we are here. We have already discussed this, and these are default sensors, right? You don't want to connect these sensors separately. Accelerometer level is, meter is there, light level is there, compass heading is there, temperature is there. These are by default in the board itself. So no need to connect that separately. And we discuss about Arduino now, and we discuss about the components. There are 4 versions of Arduino. The version that we have used is Arduino UNO board. But for the large projects, you have something called Arduino Mega. For small projects, you have Arduino Nano and Arduino Micro. These are relatively small boards, small development boards. Those are also available. In case if you need, you can use this for your projects. But so UNO is more convenient. Breadboard wiring, we discussed. The wiring connects this way. The minus and plus pins connect horizontally, and vertical connection is there for the middle pins. We learned about that as well. Then today we discuss about the passive infrared sensor, PIR, or the passive infrared sensor that we have discussed today, and how these adjustments can be done. The other side, you have the delay adjustment and sensitivity adjustment, right? So sensitivity can be increased, delay can be decreased or increased. You can see. Okay, then the positive terminal need 5 voltage to activate this VCC, and GND for the grounding. Output terminal will output 3.3 voltage in case if it detect a motion. Then with next day we will be discussing about this ultrasonic sensor and how it works, and we'll create a project using ultrasonic next day, and that is how we can create like we can measure the distance. PIR sensor is basically for the object detection, and ultrasonic can be used for distance measuring, and also obstacle avoiding robot is programmable, can be created using this ultrasonic sensor. let's discuss that next day. And with that, the particular topic will be over by next day, and we will be starting the computer network part, which is chapter 5. That is a short chapter. We will be learning about the hardware and technical details related to that chapter. And final chapter is ICT and society. Okay, then good night. See you all next week.
Good night, sir. Thank you, sir.